The engineering work before Assault was not a side story to the tank battle. It was one of the reasons the tank battle unfolded as it did. In the hours after the withdrawal from Kemkaran, Indian forces began turning the ground around Assault into a place hostile to armored movement. Mines were laid in haste, irrigation water was used to soften and flood selected areas, and likely approaches were studied for where tanks would be forced to move. This was quiet, urgent labor compared with the later drama of burning tanks and direct fire. Yet in armored warfare, preparation often decides what courage and machinery can accomplish when the shooting begins. If you would like to move beyond the podcast, you can see my available books at militaryauthor.me. And at trackpads.com, you will find magazines and galleries with hundreds of thousands of photos and videos to explore. Engineers are sometimes invisible in popular accounts of battle because their work happens before the most dramatic moment. They dig, measure, mark, carry, wire, demolish, repair, and improvise under pressure, often with little time and less recognition. At Assault-Uttar, their task was to reduce the freedom of Pakistan's armor. A tank force wants routes, room, and speed. It wants to move around resistance, bypass strong points, and keep pressure on the defender before a stable line forms. The engineer's answer is to deny smooth movement. Mines, obstacles, damaged roads, flooded fields, and prepared demolitions do not need to destroy every tank. They need to slow the formation, break its rhythm, and make it predictable enough for other weapons to strike.
Mines were especially important because they changed the psychology of movement. A minefield is not merely a hidden explosive belt. It is a warning that every track, field edge, and bypass may carry danger. Tank crews advancing into suspected mines must slow down, bunch up, or wait for engineers to clear lanes. If they push through too boldly, vehicles may be disabled and routes blocked. If they pause too long, artillery and anti-tank fire can find them. This is why mines work best as part of a larger defensive design. A mine that disables one tank can be useful. A minefield covered by guns, artillery, infantry, and observation can turn a whole armored thrust from movement into exposure.
The minefields around Assault-Uttar were laid under time pressure, not as part of a leisurely fortress plan. That mattered. Engineers and infantry had to work quickly, often at night or in conditions of confusion, while the enemy threat was approaching. The defense could not assume that every obstacle would be perfect, continuous, or fully recorded. Hastily laid mines can create problems for friendly troops as well as the enemy if marking and communication are poor. Still, speed was essential. The Indian aim was not to build an impenetrable wall. It was to put enough danger into the likely tank approaches that Pakistani armor would lose the freedom to maneuver confidently. In a fast battle, imperfect obstacles placed in time can be more valuable than perfect obstacles completed too late. Flooding added another layer to the defense. The country around Assault-Uttar was agricultural land shaped by irrigation, and water could be made into a tactical obstacle. By releasing or directing water into low areas and fields, Indian forces made parts of the ground softer and more difficult for heavy tanks to cross. This did not turn the entire battlefield into a lake, and it should not be imagined as a magical flood sweeping vehicles away. Its value was more practical and more subtle. It made drivers cautious, reduced the usable width of advance, increased the risk of bogging, and pushed armored movement toward firmer and more predictable routes. Once tanks are channeled, defenders can plan fires with far greater confidence.
The combination of mines and water was stronger than either measure alone. A field that looked passable might be wet enough to slow a tank and mined enough to punish a wrong turn. A road that seemed safe might become crowded because nearby ground had become suspect. A bypass that promised quick movement might funnel vehicles toward a prepared anti-tank position. This is how terrain becomes a weapon. The defender does not need to change every part of the landscape. He needs to change the attacker's choices. Around Asal Uttar, the Indian defense increasingly forced Pakistani armor to choose between slowing down, concentrating, or entering ground where hidden weapons and waiting tanks could exploit the delay.
The engineers' work also depended on infantry and local knowledge. Infantry holding villages and field edges could protect obstacles from being cleared easily. They could observe movement, report where tanks were probing, and cover gaps that mines alone could not close. Local terrain knowledge mattered because a map may show roads and villages, but it does not always reveal where water sits after rain, which track is firm enough for heavy vehicles, or how tall crops affect visibility from a tank turret. Civilians' land became part of the battlefield, often at great cost to ordinary life. Fields that had been planted for harvest were turned into defensive zones. Irrigation meant for agriculture became a military instrument. War consumed the landscape as well as the armies.
Artillery gave the obstacles their bite. A minefield that is not covered by fire can sometimes be breached, bypassed, or accepted as a cost. A minefield covered by artillery becomes a trap that punishes delay. When tanks halt to search for lanes, when engineers come forward to clear paths, or when vehicles bunch at a narrow crossing, artillery can multiply the effect of the obstacle. It can separate tanks from their infantry, force crews to close hatches, disrupt communications, and make commanders hurry decisions they should make carefully. The same was true of Indian tanks positioned to fire into likely approaches. Mines and flooding did not win the battle by themselves. They made the targets appear where other arms could engage them.
This is the essence of combined arms in defense. Infantry without obstacles can be overrun. Obstacles without fire can be cleared. Tanks without infantry can be ambushed or isolated. Artillery without observation may miss the decisive moment. Engineers without protection may never finish their work. At Afzal Uttar, the Indian defense began to matter because these elements were gradually tied together into a system. The system was not flawless, and it was built under pressure, but it had a clear purpose: slow Pakistani armor, channel it into known spaces, and strike it when its strength was compressed. The beauty of such a defense is not beauty in any romantic sense. It is the grim practicality of making the enemy fight the battle he hoped to avoid.
The Pakistani armored plan depended on keeping momentum after the capture or bypassing of forward positions. Mining and flooding attacked that momentum directly. A tank column that must investigate ground, avoid suspected mines, wait for support, or turn away from soggy fields is no longer moving at the speed imagined in the original plan. Its commanders may still believe they are advancing, and at moments they may still gain ground, but the offensive begins to lose tempo. Reports become uncertain, formations spread or bunch at the wrong times, and opportunities for coordinated defense increase. In armored warfare, this slowing effect can be decisive. The tank does not become weak, but the armored formation becomes less able to impose its will.
The work also had a moral and psychological effect on the defenders. A unit waiting in open country for enemy armor can feel terribly exposed. A unit that has mines forward, flooded ground on the flanks, artillery registered, and tanks in prepared positions has a different sense of possibility. The danger remains real, and no obstacle removes fear. But preparation gives soldiers a reason to believe that the enemy's strength can be managed. That belief matters in battle. It helps infantry hold when tanks approach, helps gun crews wait for a better shot, and helps commanders resist the urge to abandon a position too soon. Defensive engineering is therefore not only physical work, it is a way of giving shape to courage. In the longer history of tank warfare, Asal Uttar's mining and flooding belong to a repeated lesson. Tanks changed war by restoring movement to battlefields that had become static, but defenders repeatedly learned to use obstacles, terrain, and firepower to slow that movement again. The answer to armor was never just a bigger gun or a thicker plate. It was a system that included mines, rivers, towns, bridges, artillery, air attack, anti-tank weapons, and disciplined troops who knew why the enemy had to be delayed. From the First World War to late 20th century mechanized combat, the contest has often been between the attacker's desire for speed and the defender's ability to fracture that speed. Assault-Uter was a classic example in post-1945 form. Mining and flooding mattered because they helped decide the battle before the main clash reached its full violence. They did not guarantee victory, and they did not spare soldiers from close fighting, artillery fire, or the terrifying pressure of tanks at short range. But they made the battlefield less friendly to Pakistan's armored plan and more favorable to Indian defensive adaptation. They turned fields into obstacles, water into delay, mines into uncertainty, and uncertainty into targets. When the Pakistani attack came, it would not enter an empty space waiting to be overrun. It would enter ground already changed by hands working in urgency and danger. Assault-Uter was won by men firing weapons, but it was also won by men who prepared the ground beneath the tanks.
You've been listening to Famous Tank Battles. These battles were never just about machines. They were about doctrine, terrain, firepower, logistics, and the hard problem of turning shock into victory. For more military history writing and books, visit militaryauthor.me. And for magazines, podcasts, and a massive archive of military photos and video, visit trackpads.com. Thanks for listening.